Good day, seniors. This video lesson is about another integration technique called integration by partial fractions. Now, I have to divide this technique into two videos. So this first video would be integration by partial fractions, focusing on non-repeating irreducible factors. You will know what this means as we proceed. Now, let's have this example, integral, this given integral. Now, the goal of this technique is to make this complicated fraction into sum or difference of simpler fractions. That's why it's called partial fractions. Now, the first step is always to factor your denominator, and I already prepared it. So this is now, the denominator is now factored. Now, to make this into simpler fractions, you will make it into this. You see that we now have three fractions. We now have three fractions whose denominators are the factors x, 2x plus 1, and x minus 2. And notice that all the factors are linear in nature. By linear, we mean that the degree is 1, the power is 1. So it's this and this. Now, in decomposing this fraction into these three fractions, what is happening is that the denominators, the numerator will have a degree that is 1 less than the denominator. So if the degree of the denominator is 1, then you make the numerator 1 degree less. So the degree is 0, meaning the numerators of these three fractions will be constants. And let's have them as A, B, and C. So all we need to do is to solve for the values of A, B, and C. Now let's write it. Let's write the fraction as 9x squared minus 7x minus 2 all over the factors x, 2x plus 1, and then x minus 2. It's equal to A over x, and then B over 2x plus 1, and then C over x minus 2. So in solving for A, B, and C, we first multiply both sides of this equation by the LCD. You know, the LCD would be this 3. Okay, so when you multiply the LCD to the left side, what will be left is simply the numerator, 9x squared minus 7x minus 2. And then the right side would become, when you multiply the LCD by this, x will cancel out, leaving you with 2x plus 1 and x minus 2, which will then be multiplied to A. So that will become A times the quantity x minus 2 times the quantity 2x plus 1. Plus, the next, we multiply the LCD to this, 2x plus 1 will cancel out, leaving you with x and x minus 2, which will you multiply to B. So that becomes bx times x minus 2. Then lastly, multiply the LCD by this, x minus 2 will cancel out, leaving you with this 2, which you will multiply to C. So that's cx quantity 2x plus 1. Okay, now before we proceed, let me erase part of my solution. Okay, now, in solving for A, B, C, we will do a simple trick. We will make a term in the right side 0. So what value of x will we use? So we use x equals 2. Notice how this will come 0, this thing. And so it's this. So what will be left will be this term. Substitute your x. This will become 2 times 2, 4 plus 1, 5 times 2, that's 10, C. So that will become 10C. Equal to, substitute 2 here, you get this, it's 9x squared, 2 squared 4 times 9, 36, minus 14 minus 2, that's 36 minus 16, or 20. Therefore you get C equals 2. So now you have the value of C. Now having x equal to 0 will make this term 0, and as well as this. So what will be left will be this, which you can now substitute 0. 0 minus 2, that's negative 2. 0 plus 1, that's 1. So it's negative 2a in one side, and in the other side 0 minus 2 is negative 2. So a now would be obtained, and it's equal to 1. Now let's have another technique in solving for the missing b. I call this by simply inspecting a term. So notice how when you multiply, if we focus on a term first, let's say focus on x squared. Notice when you multiply this term, a term in that will have x squared would be here ax, 2x, that will become 2ax squared. So here in this term, a term that will have an x squared would become is bx squared. And here, a term that will have an x squared is this time 2x times cx, that's 2cx squared. And of course, it's equal to the only term in the left side which has an x squared, which is 9x squared. And it's no problem now because we have the value of a and c. So this is 2x squared because a is 1. That's bx squared, that's what we're looking for. And then c, if c is 2, then this must be 4x squared. So if c is 2, and it's equal to 9x squared. So it's now clear that b must be 2, 4, that's 6. So b must be 3, so that the right side is 9x squared. So now you have the values of a, b, and c. So we know that a is 1, b is 3, and c is 2. So it's now your given integral at the start, which is a complicated fraction, is now this sum of these simpler integrals, and it's now easy to integrate. So it's equal to ln x for the first. For the second, we have to use the substitution. So because the denominator is 2x plus 1, then du will have become 2 dx. Therefore, that integral becomes, let's put 3 outside, and then over u, because 2x plus 1 is u. Now, dx will be replaced with du over 2, that putting 2 outside, du, this is now 3 halves of ln u. So we know that this will become 3 halves ln of u, which is your 2x plus 1. There, 2x, and then this is simple because if you let u be x minus 2, the u is still dx. So this is simply 2 ln of x minus 2, and then plus c. That's the integral. Now let's move on to the next. Okay, now we have here this another complicated fraction. We can do substitution here. Again, the first step is always to factor your denominator. So it's simply x going to the x squared plus 2x plus 1, and then you make this into its sum of simpler fractions or partial fractions. This now notice that your factors are x, a linear in nature, and then x squared plus 2x plus 1, which is a quadratic of the second degree. Notice also that your quadratic can no longer be factored. That's why the term irreducible factors. So there you go. Now remember that I said earlier that the degree of the numerator should be 1 less than the denominator, so it's degree 1, therefore the numerator should be a constant. Now the degree of the denominator, our denominator is 2, it's quadratic, therefore the degree of the numerator should be 1 less, so it should be linear. So if it's linear, it must be of the form bx plus c. Now I will do this quickly. Just multiply by the LCD. We will get here 2x squared minus 2 is equal to the LCD divided by the x. So will you with the other factor which you multiply to a. So that's a times the quantity x squared plus 3x plus 1 plus the LCD divided by this. So that will be left with x. You will be left with x, which you will multiply to this group bx plus c. So it's bx plus c times x. So now let's solve this by inspection. Let's have x equals 0. So because this will become 0 and it will disappear. So you can substitute 0 to x. This will be 0 plus 3, 0 plus 1 times a. So that's a. And then 0 minus 2, so negative 2. So we have value of a. Now we have to do the inspection thing to get the other values, the values of b and c. Now let's inspect all the terms with x squared first. So here you will have an x squared. So that's ax squared. And here when you multiply bx and x, you will have another x squared. So bx squared. And it's equal to the only term in the left side with an x squared, and that's 2x squared. So if you have a already, it's negative 2x squared. What do you think b must be? So just write it like that. So b must be, it's clear that b must be here equal to 4. Okay, now to get c, notice that when you distribute this, c will have to be the term with an x. So here the term with an x must be a times that, so that's 3ax, plus the term with an x in the second term must be cx, and it's equal to, notice the left side does not have a term with an x, so it must be 0. So if a is, if we know a is negative 2, this must be negative 6x, then plus cx equals 0. That only means that c is 6. So now we have the values of a, b, and c. Then this must be negative 2 here, and then 4x plus 6. Remember, it's bx plus c, so it's 4x plus 6. Now we have this integral to deal with. Much simpler integral, these two. So the first is very simple. It's simply negative 2 ln x. Then the other we have to do by simple substitution, by letting u be the denominator, x squared plus 3x plus 1. Then your du must be 2x plus 3, and then dx, of course. But in the numerator it's 4x plus 6, so it's simply multiplying both sides by 2 to take care of 4x plus 6, because if you do that, this becomes 4x plus 6 dx, and it's equal to 2 du. Therefore that integral becomes 2 outside, du over u, which is simply 2 ln of u. So writing it here, it's 2 ln of u, which is x squared plus 3x plus 1, and then of course plus c at the end. There you go. So this is partial fractions. Now on to my favorite part, the best way to learn, so do it yourself. Do not forget that you need to practice. Now I have here these two integrals. I want you to solve this on your own. These are the answers. I really suggest that you try to do this and answer this on your own. Good day, seniors.